Beneath the seemingly endless white expanse of the Arctic ice lies a monumental secret: vast mountain ranges, taller and more extensive than the famous Alps, hidden for millennia beneath a thick, frozen veil. This isn't speculation or myth, but a revelation uncovered by the extraordinary power of ice-penetrating radar technology. For decades, the Arctic has been perceived as a barren, inhospitable wasteland, a frozen desert of ice and snow stretching to the horizon. Yet, beneath this frozen silence, a dynamic and ancient landscape remains utterly concealed, its peaks and valleys preserved with breathtaking clarity under layers of ice that have withstood the tests of time. This documentary invites you to embark on an immersive journey into this hidden world, a realm where science peels back the curtain of ice to expose the grandeur of mountains that have shaped Earth's history and climate for millions of years. Ice-penetrating radar, a marvel of modern science, acts as our eyes beneath the ice. By sending radio waves through thick ice sheets that would stop light entirely, this technology captures echoes bounced back from the ground below. These echoes are transformed into detailed maps, revealing terrain features invisible to the naked eye. In the Arctic, this method has uncovered a secret mountain realm: ranges that tower higher and stretch further than the Alps or any mountain chains above ground. The discovery transforms our understanding of the Arctic from a flat, frozen wasteland to a complex, rugged landscape shaped by tectonic forces and sculpted by ancient rivers before the ice claimed it. These mountains have lingered hidden, their crowns trapped beneath kilometers of ice, silent witnesses to Earth's climate cycles and geological evolution. What makes this frozen world so mesmerizing is not only its size but the preserved wonders it holds. Beneath the Arctic ice lie ancient river valleys, vast networks of channels carved by meandering waters long extinguished by glacial encroachment. These valleys, once nurtured by flowing rivers, now lie impeccably preserved as if suspended in time. The ice acts as a vault, shielding this petrified landscape from the battering forces of wind and weather that shape the surface and from the slow erosion that would have erased these traces under normal conditions. As a result, scientists can peer back into an epoch when the Arctic was warm enough to support flowing water, lush ecosystems, and a planet very different from today. This geological time capsule offers more than just awe. It grants critical insight into Earth's climatic past, helping researchers reconstruct the natural rhythms that led to ice ages and warm interludes. The shapes of these hidden mountains and valleys provide evidence of how ice sheets advanced and retreated, influencing global sea levels and ecosystems far beyond polar regions. The bedrock beneath them, composed of ancient granite, basalt, and sedimentary layers, tells epic stories of tectonic plate collisions, rifting, and the slow but relentless shaping of continents. Each echo captured by radar is a message from the deep past, an unbroken record waiting for humanity to decode. Glaciation has left a profound mark on this landscape. The grinding movement of massive ice sheets carved channels and sculpted peaks, entombing the terrain beneath an unyielding frozen blanket. This process locked these mountains in a perpetual winter, shielding them from change for tens of thousands, even millions, of years. But now, the story is changing. The modern climate crisis is slowly thawing this icy fortress. As temperatures rise, parts of these hidden mountains are beginning to emerge from the ice, offering scientists an unprecedented opportunity to study geological features long shielded from direct observation. This thaw is not only a scientific revelation but also a cautionary signal about the fragile balance of polar ecosystems and the future of global environments. The challenge of exploring these subglacial mountains cannot be overstated. The Arctic's remoteness, coupled with extreme cold, unpredictable weather, and the thickness of the ice itself, makes physical expeditions nearly impossible. Radar technology enables a remote sense of exploration, revealing landscapes no human has set foot upon in modern times. As the ice retreats, each newly uncovered peak and valley becomes a chapter in Earth's unfolding story, carrying clues critical for understanding glacier movements, ice dynamics, and the feedback effects on global climate systems. Perhaps the most intriguing question that arises from these findings is whether life could exist beneath this ice. In other parts of the world, such as Antarctica, subglacial lakes have been found isolated under thick ice, harboring microbial life that survives in total darkness and isolation. Could the Arctic's subglacial valleys also shelter such hidden ecosystems, sealed away from sunlight and the external world for eons? If so, this frozen world might not only be a geological archive but also a cradle of exotic life forms thriving in conditions once thought impossible. This discovery in the Arctic also echoes parallels with the Antarctic's mysterious subglacial mountain ranges, such as the Gamburtsev Mountains, which are similarly concealed beneath enormous ice sheets. Both poles hold vast subterranean mountain ranges waiting quietly beneath their icy crowns, landscapes so foreign yet so integral to the global system. Understanding these hidden features at both ends of the Earth is essential for building comprehensive models of ice sheet behavior, climate change impacts, and sea level projections that affect millions worldwide. Ultimately, unveiling the Arctic's subglacial mountains redefines what we know about the planet's frozen frontiers. These mountains are more than rock and ice, they are monumental storytellers of Earth's geological past and sentinels of its uncertain future. As the ice continues to shift and melt, these once-forgotten peaks will emerge from their long winter sleep, revealing secrets that could reshape science, inspire wonder, and deepen our appreciation for the hidden complexities beneath the ice. This journey beneath the frozen surface is an invitation to witness a hidden kingdom, where ancient forces and modern science meet, opening new horizons of discovery in the quietest, coldest reaches of our world. Ice-penetrating radar, often referred to as the keyhole into the Arctic's hidden world, is a technology whose roots stretch back decades but whose application today is nothing short of revolutionary. At its core, this technology harnesses the subtle interactions between radio waves and the ice sheet, a seemingly impenetrable fortress that to ordinary senses is just a vast, homogeneous white blanket. But beneath its smooth exterior, ice holds secrets etched in its terrain, topology, and history. The process begins with the emission of electromagnetic waves, carefully tuned to penetrate deep into ice layers, bypassing their dense yet transparent nature to radio frequencies. As these waves travel downwards, they gently collide with interfaces where properties change. This could be the boundary between different ice layers, or, most importantly, the bedrock beneath that ice. At each interface, a portion of the waves reflects back to the surface, while others continue deeper, accumulating information layer by layer. The returning echoes are collected and processed into radargrams, detailed cross-section visualizations of the subsurface beneath the points where the radar pulses originated. These radargrams are much more than abstract lines, they are three-dimensional maps etched in waves, revealing not only the thickness of the ice but the contours of mountains, valleys, and ancient channels below. In the Arctic, this technique has been deployed from aircraft, drones, and satellites, enabling coverage of vast areas otherwise inaccessible to human explorers. The captured datasets are processed through intricate computational techniques, removing noise and compensating for the subtle distortions caused by the ice's varying properties, before revealing the full, stunning complexity of the sub-ice landscape. Unlike traditional mapping, which depends on direct observation and surface access, ice-penetrating radar allows scientists to peer into a world frozen beneath layers of ice for millennia. It transforms our understanding of the Arctic basin from a blank map of ice-covered flatness to a rich geological tapestry, a landscape of peaks and valleys hidden in plain sight. But the stories uncovered by radar go beyond mere geography. Each mountain peak beneath the ice tells a tale of ancient tectonic forces that shaped the planet long before the Arctic glacier took hold. These mountains formed millions of years ago, their origins entwined with continental drift, volcanic activity, and the slow grinding of the Earth's crust. Studying their shapes and compositions has revealed how different parts of the planet collided and separated, providing clues not only about the Arctic's past but about the very movements that crafted today's continents. The method has uncovered vast mountain ranges stretching under the ice sheet, some rising several thousand meters above the surrounding terrain. These ranges rival the grandeur of known surface mountains yet remain undiscovered until radar technology unveiled them. Their existence challenges previous assumptions that the Arctic floor was relatively flat and featureless. Instead, it is a rugged, ancient landscape sculpted over eons, now hidden beneath ice that averages over 2 kilometers in thickness. Scientists have also identified deep, sinuous valleys carved into bedrock, often hundreds of kilometers long, tracing ancient river pathways that predate the ice's expansion. These valleys reveal that the Arctic was once a far warmer region, home to flowing water and dynamic ecosystems. It paints a picture of a time when life flourished, and the Arctic was a very different environment from the frozen expanse we know today. The preservation of these valleys is extraordinary. Encased in ice, shielded from erosion, and insulated from direct sunlight and wind, these landscapes are time capsules of Earth's climatic history. Radar has revealed these channels in unprecedented detail, enabling scientists to reconstruct past environments and understand not just how the ice advanced but how the planet's climate system fluctuated over millennia. Such detailed understanding is essential in the current age, as climate change accelerates the melting of polar ice. Knowing the hidden terrain beneath the ice sheets can significantly improve models predicting ice flow and melting patterns. The shape of the subglacial landscape influences how ice moves and where meltwater flows beneath the ice, impacting the stability of glacier and the rate of sea level rise globally. The ice sheet's thickness and the bedrock's varying elevation significantly control ice dynamics. When warm water encounters these mountains and valleys, it can accelerate melting or redirect glacial movements. Radar data help refine these predictions, making them invaluable to policymakers and scientists seeking to mitigate the impact of climate change. Moreover, ice-penetrating radar surveys have opened new avenues for exploration beyond geology. They hint at the existence of subglacial lakes, liquid reservoirs trapped beneath kilometers of ice, kept from freezing by pressure and geothermal heat. Some of these lakes may be home to unique microbial ecosystems that have survived in isolation for millions of years, untouched by surface life. Discovering and exploring these subglacial lakes can broaden our understanding of life's resilience and adaptability. It also informs astrobiology, offering analogues for icy worlds beyond Earth, such as the subsurface oceans hypothesized on moons like Europa or Enceladus. The Arctic's hidden lakes and mountains, thus, not only reveal Earth's history but also inspire questions about life's potential in the cosmos. The logistic challenges of obtaining radar data in the Arctic are immense. Harsh weather conditions, remote and inaccessible terrain, and the sheer thickness of ice require highly specialized equipment and planning. Aircraft equipped with advanced radar systems fly in carefully coordinated missions, sometimes enduring freezing temperatures and unpredictable storms to collect data. Satellites complement these missions with broader but less detailed coverage, painting a comprehensive portrait of the frozen North. Every pulse of radar that returns data is a triumph over nature's barriers. Scientists must painstakingly interpret these signals, distinguishing real geological features from artifacts or noise caused by ice properties or equipment limitations. This delicate process involves collaboration across disciplines: geophysics, glaciology, computer science to transform raw data into meaningful maps and models. As the ice melts increasingly due to warming temperatures, these hidden landscapes draw more scientific focus and urgency. Newly exposed ridges and peaks offer rare opportunities for direct sampling and observation, which could confirm radar findings and reveal new details about the geology and ecology beneath. Expeditions now plan to reach places never before touched by human presence, potentially rewriting textbooks about Earth's polar regions. The discovery of Arctic subglacial mountains not only changes what we know about the Earth's physical geography but expands our view of the planet's dynamic systems. It underscores the Arctic's role as a key player in global climate, a region where changes beneath the ice ripple across oceans and atmospheres, influencing weather and sea levels far away. In many ways, this hidden mountain world felt like a blank spot on the map until radar technology lifted the veil, revealing a rugged, ancient realm frozen in time. It invites us to rethink the Arctic not as an empty, frozen desert but as a complex, vibrant system with deep roots in Earth's history and its future. The mountains beneath the ice are silent witnesses to the powerful forces that shape our planet and remain a frontier of discovery, waiting to be explored and understood. Through the lens of ice-penetrating radar, humanity gains a profound new perspective on the Arctic, a perspective that reveals its mystery, majesty, and crucial significance in the delicate balance of our changing world. The story of the Arctic's subglacial mountains is one of discovery that combines cutting-edge technology with patient scientific inquiry, a narrative unfolding through persistence and innovation. It begins not just with the technology, but with the questions scientists have long sought to answer about the polar regions. For years, surface ice sheets were the only visible evidence of the Arctic's complex geological past. The vastness of ice hid the underlying terrain from view, leaving maps incomplete and understanding of the region's geology fragmented. The deployment of ice-penetrating radar transformed this landscape of ignorance into a landscape of revelation. This technology, capable of delivering precise measurements of ice thickness and underlying terrain, allowed scientists to sketch the hidden topography with unprecedented detail. With each pulse of radar sent through the ice, the layered story of the Arctic's geology and climate history became clearer. The raw data, once collected, undergoes sophisticated processing to extract meaningful information. Scientists correct for ice temperature variations, density differences, and other factors that affect signal speed and quality. This ensures that the maps and models generated represent the true shape and structure beneath the ice. One of the most striking findings revealed by radar surveys is the sheer scale of mountain ranges beneath the ice sheet. These ranges stretch across hundreds of kilometers, with towering peaks that rival the Alps and other famous mountain systems on the Earth's surface. The presence of these hidden giants challenged long-standing assumptions about the topography of the Arctic Ocean floor, prompting revisions to geological models of the Northern Hemisphere. These mountains are remnants of tectonic activity that shaped the region millions of years ago, long before the onset of the current glaciation. The Arctic's geological history includes episodes of continental collision, rifting, and volcanic activity, events that have left their imprint in these mountain formations. The shapes of the peaks, ridges, and valleys tell a story of immense forces that have combined to create this hidden landscape. Moreover, the hidden valleys beneath the ice, many of which were carved by ancient rivers, offer a glimpse into a pre-glacial world. These river pathways once channeled water through a much warmer Arctic, supporting ecosystems that thrived under different climatic conditions. The preservation of these valleys under the ice offers a unique record of Earth's climate dynamics, providing insights into how the Arctic transitioned through glacial and interglacial periods. Understanding the structure and composition of these subglacial mountains is critical not only for reconstructing past environments but also for predicting future changes. As the Arctic experiences unprecedented warming, the stability of its ice sheets becomes a crucial concern. The bedrock topography beneath the ice influences how glaciers move and how quickly ice can melt and flow into the ocean, contributing to sea level rise. The intricate dance between ice and rock beneath the Arctic is complex. In places where mountains rise steeply, glaciers may be anchored, slowing their movement. In contrast, in deep valleys or basins, ice can flow more rapidly, creating pathways for water to circulate beneath the sheet. Meltwater trapped in subglacial lakes or rivers can lubricate the ice's base, accelerating glacial motion. Radar data helps scientists identify these geographic features and incorporate them into predictive models. In addition to geological insights, the use of radar has opened doors to a better understanding of the Arctic's hydrology beneath the ice. The discovery of liquid water bodies, subglacial lakes and rivers has changed perceptions of the region. These lakes, often buried under several kilometers of ice, exist in stable liquid form because of the immense pressure from the overlying ice and the geothermal heat produced by the Earth's interior. The presence of such lakes raises fascinating questions about life in extreme environments. In Antarctica, similar subglacial lakes have been found to host microbial life, raising the possibility that life could exist beneath the Arctic ice as well. These isolated ecosystems survive in complete darkness, under high pressure and low temperatures, sustained by chemical energy sources. Exploring these lakes could not only advance biology but also teach us about potential life on icy moons and planets even further afield. Collecting radar data to study these features comes with great challenges. Scientists rely on specially equipped aircraft, such as research planes outfitted with ice-penetrating radar instruments, or satellites orbiting the Earth that carry sensors capable of obtaining radar echoes from the ice surface and below. Each platform offers its own advantages and limitations, balancing coverage area, resolution, and operational constraints. Field campaigns require meticulous planning and execution. Teams must contend with extreme cold, logistical difficulties, and the inherent dangers of operating in remote Arctic environments. Flights must be carefully timed to make use of appropriate weather windows, minimizing the risk of accidents and ensuring optimal data quality. Once data is collected, months if not years can be spent in analysis as researchers extract signals from noise and interpret complex patterns. The information revealed by these radar studies is already reshaping scientific understanding and informing climate policy worldwide. knowing the precise topography and ice dynamics allows for improved predictions about how Arctic ice sheets might respond to warming, and how much meltwater they will contribute to global sea levels. This knowledge is essential for coastal cities and vulnerable communities globally preparing for the realities of climate change. The unveiling of these subglacial mountain ranges is not just a scientific achievement, it represents a profound shift in perception of one of the last great frontiers on Earth. What was once thought to be a remote, frozen wasteland is now understood as a dynamic, textured landscape with a deep history. The Arctic's hidden mountains and valleys are chapters in the Earth's storytelling of previous worlds, of forces that shaped continents, and of the ongoing interplay between ice, rock, and life. Through ongoing research and technological innovation, humanity is peeling away the layers of mystery surrounding the Arctic. Each discovery marks a step closer to truly understanding this frozen realm that plays such a crucial role in Earth's climate system. As the ice melts and the glacier retreat, these hidden mountains will gradually emerge into view, changing not only the landscape but also our understanding of the natural world. This gradual revelation serves as a reminder of the importance of continued scientific exploration, international cooperation, and stewardship of the planet's polar regions. The Arctic, with all its mysteries beneath the ice, remains a vital component of the Earth's delicate environmental balance and an emblem of how much there is still to learn about our world. As the Arctic's icy veil gradually retreats in response to a warming climate, the hidden subglacial mountain ranges begin to emerge not only as scientific curiosities but as vital witnesses to Earth's past and harbingers of its future. Their revelation invites deeper inquiry across multiple scientific disciplines from geology and glaciology to climate science and biology, each seeking answers to questions that the mountains silently hold. The study of these hidden ranges provides a unique lens through which to observe Earth's tectonic and glacial histories. Beneath the ice, the interplay between geological structures and ice dynamics governs not only the physical stability of the glacier but also the global climate feedback systems. Mountains act as anchors, creating resistance that can stabilize ice sheets by slowing their flow toward the oceans. Conversely, valleys and basins may facilitate faster ice movement, as meltwater lubricates the ice base, accelerating ice discharge. This nuanced topography modulates the Arctic ice sheet's behavior during warming periods. Understanding its impact is critical because it influences the volume and velocity of ice loss, which directly feeds into projections of future sea level rise. The radar technology that unveiled these features now enables real-time monitoring of glacial responses to changing temperatures. Continuous data collection and analysis form the backbone of predictive climate models, which are integral not only to scientists but also policymakers crafting responses to global warming. Moreover, the mountains function as natural laboratories for studying past climate cycles. Ice cores extracted from above these subglacial features contain climatic records that date back hundreds of thousands of years. These cores capture ancient atmospheric compositions, dust, and volcanic ash layers, enabling reconstruction of temperature patterns and environmental conditions across millennia. When combined with radar-derived topographical maps, such data paint a comprehensive picture of how the Arctic has evolved through ice ages and warmer interludes. The ancient river valleys hidden beneath the ice hold equally compelling stories. Their preservation beneath kilometers of ice allows scientists to peer into epochs when the Arctic was an unrecognizable landscape lush, with flowing water and verdant ecosystems. Such findings challenge long-standing notions of polar barrenness, revealing biodiversity and ecological complexity that flourished long before the ice arrived. They also hold clues about how landscapes respond to extreme climate shifts, providing analogues that can inform predictions of current environmental transformations. Beyond geology and climate, the Arctic's subglacial realms hold mysteries that touch on the origins and extremes of life itself. The discovery of subglacial lakes, insulated from surface conditions, suggests isolated environments where microbial life could exist independently, relying on chemical energy rather than sunlight. These unique ecosystems push the boundaries of what is known about possible habitats for life, particularly in extreme conditions. They spark interdisciplinary collaborations between geologists, biologists, and astrobiologists aiming to understand life's adaptability and resilience. Explorations of subglacial environments often confront extreme technical and logistical challenges. Annual expeditions require meticulous planning, not only due to Arctic conditions but also because of the sensitive nature of these pristine environments. Protecting the integrity of subglacial lakes and mountains means strict protocols govern drilling and sampling operations, designed to avoid contamination that could disrupt native ecosystems or obscure scientific findings. Technological advances continue to expand the capabilities of ice-penetrating and other remote sensing methods, enhancing resolution and spatial coverage. Autonomous vehicles equipped with radar and sampling devices promise new breakthroughs in accessing areas currently impossible to study directly. Innovative satellite missions, some employing synthetic aperture radar, provide ongoing global observations, complementing airborne and ground-based campaigns by delivering continuous data streams across seasons and years. The insights gained from Arctic subglacial mountains have policy implications that extend far beyond the polar regions. Global sea levels are sensitive to changes in ice sheet mass, and even small accelerations in ice loss can have profound impacts on coastal populations worldwide. Improved accuracy in predicting the timing and magnitude of these changes helps governments and communities prepare and adapt to ongoing environmental shifts. Beyond practical considerations, the revelation of these mountains enriches our understanding of Earth as a dynamic planet. They are reminders of the complex interactions between geology, climate, and life. Their hidden grandeur invites profound reflection on the resilience of nature and the fragility of the systems that sustain human civilization. Acknowledging the importance of the Arctic subglacial mountains goes hand in hand with recognizing the urgency of preserving polar environments. As these regions warm faster than almost anywhere else on Earth, human activities, whether scientific, industrial, or commercial, must be carefully managed to minimize impact. International cooperation and governance frameworks ensure that exploration proceeds responsibly, balancing curiosity with conservation. The Arctic remains one of the planet's final frontiers, not only in terms of geography but also in scientific understanding. Each new discovery beneath its ice ushers in deeper questions and possibilities, reinforcing the need for sustained investment in polar research. This commitment is vital to uncovering the complexities of the Earth system and responding effectively to climate change challenges. In closing, the subglacial mountains beneath the Arctic ice are more than hidden peaks beneath frozen sheets. They are emblematic of Earth's layered history and ongoing transformation. They stand as silent sentinels, watching the unfolding story of a planet in flux, guiding humanity's journey of discovery, understanding, and stewardship. Exploring these landscapes invites us to marvel at the unseen and appreciate the intricate weave of forces shaping the world we inhabit. It is an invitation to witness the majestic, mysterious heart of the Arctic, quietly waiting to reveal its secrets to those willing to seek them with care and respect. The unfolding revelation of the Arctic subglacial mountains compels us to reflect on the hidden complexities of our planet. These frozen giants, once buried beneath vast sheets of glacial ice, are markers of the Earth's deep history, divine witnesses to epochs of geological creation, destruction, and transformation. Their ancient stones tell stories of shifting continents and changing climates, of life's persistence and adaptation amidst extremes. Technology has been our guiding light into this shadowy underworld. Without the advances in ice-penetrating radar and remote sensing, these mountain ranges would remain mere curiosities in scientific hypothesis rather than tangible places to be studied and understood. Radar's ability to penetrate kilometers of ice has turned what seemed like an opaque and static ice sheet into a dynamic landscape rich with geological features. Each scan takes us closer to understanding how these mountains influence the broader Arctic environment. They aren't simply inert backdrops beneath the ice, they engage in a subtle interplay with the ice masses themselves. The morphology of these mountains controls ice sheet flow dynamics, serving as barriers that slow glacial movement or pathways that direct meltwater and subglacial rivers. This interaction is essential in deciphering how the ice sheets respond to warming and how rapidly they contribute to sea level rise. Beyond their physical presence, these mountains are archives of Earth's environmental record. Layers of ice above capture atmospheric samples across time, while the mountains themselves contain rocks and minerals that reveal tectonic history. Together, they provide a temporal window allowing scientists to peer back millions of years to reconstruct the planet's climatic fluctuations and geological events with exceptional precision. What captivates us most are the preserved ecosystems once sustained by ancient rivers and valleys hidden beneath this seemingly lifeless ice. When we hear about the Arctic as a frozen wasteland, the reality beneath the ice challenges that perception. Long before these glaciers formed, the region supported vibrant landscapes, lush with life wherever rivers once flowed. The preserved subglacial river valleys offer evidence of this forgotten epoch, providing clues to the Earth's resilience and adaptability over geological timeframes. Biological inquiries into subglacial lakes and microbial life in isolated habitats beneath kilometers of ice are redefining the boundaries of life on Earth. The discovery that life can persist in these extreme, isolated environments expands our understanding of biological limits and the potential for life elsewhere in the universe. Such findings inspire deep philosophical and scientific questions about the adaptability and tenacity of life, placing the Arctic's hidden worlds at the forefront of astrobiological research. Yet, the quest to explore these secrets beneath the ice is colored by profound challenges. The Arctic's harsh climate, logistical difficulties, and the need to preserve untouched ecosystems shape the way scientific investigation proceeds. Innovations in robotics, autonomous vehicles, and drilling technology are enabling scientists to access these pristine environments with minimal disruption, ensuring that discoveries can be made responsibly and sustainably. Sustained international cooperation remains pivotal. The governance of polar science is governed by protocols that protect the environment while supporting invaluable scientific progress. Collaborative projects mobilize expertise across continents, uniting governments, research institutions, and indigenous knowledge to safeguard the Arctic while expanding our understanding. The importance of these discoveries extends to broader societal implications. As ice sheets interact with the underlying mountains, changes ripple outward, affecting global weather patterns, ocean currents, and ultimately human communities. Understanding the details of these interactions is vital for preparing for the changing planet, informing mitigation and adaptation strategies to confront climate challenges. In contemplating the Arctic's subglacial mountains, we stand at the threshold of a new phase of planetary exploration, one that embraces the hidden and the unseen, inviting us to rethink our relationship with the natural world. These mountains remind us that beneath layers of ice and snow lies a dynamic world, one whose cycles, interactions, and mysteries are sharply relevant to our present and future. This ongoing discovery is a call to cherish and protect the fragile polar environments. It is a call to invest in the tools, knowledge, and collaboration necessary to continue unveiling the Earth's secrets in a way that honors the planet's integrity. In doing so, we safeguard not only the Arctic's hidden mountains but the entire network of life connected to them. We can imagine these mountains as silent sentinels, standing guard beneath the ice, observing millennia of change with patient endurance. Their story is far from complete, yet it already enriches our perspective on Earth as a living, evolving system. As warming temperatures continue to sculpt the Arctic's landscape, these hidden peaks will gradually emerge, transforming from shadows beneath the ice into visible witnesses of planetary change. With each expedition, each radar pulse, and each data point, humanity deepens its connection to this remote and enigmatic region. It is a connection born from curiosity, respect, and a profound sense of stewardship for one of Earth's final frontiers. The mountains beneath the ice are both a reminder of what has been lost and a beacon for the discoveries yet to come. In the symphony of Earth's grand processes, these Arctic subglacial mountains play a subtle yet essential part. Their silent enormity influences the rhythms of ice, water, and climate. They shape journeys of glacier as they carve their paths toward the sea. By understanding them, we gain insight not only into grand geological scales but into the intimate, fragile threads that sustain life across the planet. Thus, the Arctic's subglacial mountains are more than geological formations. They are keys to understanding Earth's past, present, and possible futures. They demonstrate the power of human ingenuity, how technology can unveil the unseen, how science can weave disparate data into stories of profound meaning, and how exploration continues to redefine the boundaries of knowledge. Looking forward, the ongoing study of these mountains calls for both caution and optimism. As the Arctic warms, the need for accurate, comprehensive information becomes more pressing. The knowledge gained will empower societies worldwide to make informed decisions, balancing development, conservation, and resilience in a rapidly changing world. In the grand tapestry of the Earth, these subglacial ranges remind us that beneath surfaces, whether ice, ocean, or land, lie hidden worlds full of wonder, challenge, and revelation. They call us to persist in learning, to embrace the unknown, and to honor the planet that sustains us. This unfolding narrative of the Arctic's hidden mountains is a journey without end, a story of discovery, resilience, risk, and hope, inviting all who listen to join in the exploration, marvel, and stewardship of our remarkable, ever-changing planet. The Arctic's subglacial mountain ranges represent not only one of the greatest geographical discoveries of our time but also a profound source of insight into Earth's climate system and geological processes. The intricate relationship between ice and rock beneath the polar cap influences patterns that extend far beyond the Arctic itself, intertwining with global environmental dynamics affecting millions of lives. The vast ice sheets that blanket the Arctic are not homogeneous, rather, they are sculpted and directed by the hidden mountains below, which in turn shape patterns of movement, melting, and renewal. By studying these mountains and the ice that envelops them, scientists gain invaluable information about how glaciers behave under pressure and temperature changes. Variations in the thickness and elevation of bedrock directly impact how the ice flows, whether it accelerates toward the ocean or remains relatively stable. Each subtle crevice and peak modifies the internal stresses within the glacier, influencing its responsiveness to environmental changes. Through the precision of ice-penetrating radar and sophisticated modeling, researchers create ever more accurate simulations of glacier dynamics, essential for forecasting future scenarios of ice loss and sea level rise. These subglacial mountain ranges have remained out of sight for so long, manually and digitally concealed beneath kilometers of thick ice. Their discovery challenges earlier assumptions of a predominantly flat marine Arctic basin, instead revealing vigorous geological activity and complex terrain that has influenced glacial behavior for millions of years. These mountains are a testament to Earth's ongoing evolution, formed by the interplay of tectonic forces, volcanic activity, and erosion processes prior to their burial under ice. From a paleoclimatic perspective, the mountains and their accompanying valleys serve as ancient archives, preserving information about environmental shifts that predate human records. Embedded within layers of rock are fossils and minerals that speak of a far warmer Arctic world, containing clues about ecosystems that supported diverse flora and fauna long before the advent of polar ice sheets. Sediment analysis and bedrock sampling from these regions reveal cycles of glaciations and interglacial periods, furthering our understanding of natural climate variability. A growing focus is the connection between these mountains and the subglacial hydrological system. Beneath the ice, pools of liquid water exist in lakes and rapidly flowing rivers, sustained by pressure and geothermal heat. These water bodies play a crucial role in the lubrication of the ice sheet and the transportation of sediment beneath glacier. Meltwater pathways, often carved through bedrock and ice, modulate glacier velocity, influence the shape of ice sheets, and directly affect the rate of melting and carving at glacier termini. The delicate balance maintained by these subglacial hydrological networks is fragile and highly sensitive to changes in temperature and pressure. As the Arctic warms, the volume and distribution of meltwater alter, sometimes exacerbating ice loss through accelerated flow or basal melting. Understanding these hydrological systems through radar mapping and hydrological modeling is vital for accurately predicting glacier response and sea level contributions. In the biological realm, the subglacial lakes hidden among these mountains harbor life forms that have adapted to extreme and isolated conditions. Microbial ecosystems persist in complete darkness, in bitter cold, and under tremendous pressure, relying on chemical energy derived from rock-water interactions. These forms of life expand our appreciation of Earth's biodiversity and suggest possibilities for life in extraterrestrial icy environments. The exploration of these lakes, while promising, requires extreme care to avoid contamination and preserve their pristine nature. International protocols guide drilling operations to minimize impact while allowing scientists to obtain crucial biological and chemical samples. The combined use of radar and advanced microbial analysis techniques opens new frontiers in the study of extremophiles and the limits of life. Technological innovation continues to enhance our ability to map and understand these hidden mountain systems. Advances in radar resolution, autonomous underwater vehicles equipped with sensors, and satellite-based remote sensing increase the spatial and temporal detail available to researchers. This technology enables continuous monitoring of glacier behavior as it relates to bedrock topography and subglacial water flow, informing climate adaptation strategies. Moreover, the integration of indigenous knowledge alongside cutting-edge science enriches the understanding of Arctic landscapes. Indigenous Arctic communities possess profound experimental insight into ice dynamics, weather patterns, and ecological changes that complement scientific observations. Collaborations between scientists and native peoples foster mutual respect and holistic approaches to Arctic research and stewardship. Facing the future, the Arctic subglacial mountain ranges act as a reminder of the planet's complexity and the interconnectedness of its systems. Their influence on glacier stability, local ecosystems, and global climate underscores the imperative for sustained and responsible research. The data gathered guides not only scientific inquiry but also the policies and governance necessary to navigate environmental challenges and protect vulnerable communities. As these mountains slowly re-emerge from under melting ice, they also serve as a metaphor for human discovery and perseverance. They symbolize the frontier of knowledge hidden, challenging, yet full of promise. The ongoing exploration calls on us to acknowledge our responsibilities as stewards of Earth's most fragile environments, balancing curiosity with conservation. These landscapes, sculpted by unimaginable forces over eons, challenge us to think in geological time scales, understanding that today's climate change represents but another chapter in an ancient story. Our efforts to understand and preserve the Arctic's subglacial mountains parallel humanity's broader quest to comprehend its place within an evolving planet. In embracing these hidden peaks and valleys, we embrace the full complexity of the Earth system, a world where geology and climate, biology and technology, history and future converge. Each discovery beneath the ice is a testament to the endless potential for learning, reminding us that even in the coldest, most remote places, life, change, and mystery endure. Ultimately, the Arctic's subglacial mountain ranges inspire a profound sense of wonder and respect. As we continue to uncover their secrets, we deepen our connection with the Earth and affirm our role in safeguarding its future. The journey into the Arctic's frozen depths is far from over. It is a continuous invitation to explore, discover, and protect. In the silence beneath the ice, where light never reaches, the mountains stand as eternal witnesses to the planet's past and beacons guiding us toward a sustainable future. Through the fusion of technology, science, and human dedication, we illuminate their hidden majesty and unlock lessons that will resonate for generations to come. The Arctic's subglacial mountains represent an ever-unfolding story of discovery that connects Earth's ancient past with the pressing challenges of our rapidly changing present. Each peak and valley buried beneath the ice is a silent witness to cycles of formation, growth, and transformation that have shaped not only the polar realms but have also sent ripples through global systems. Their intricate interplay with the ice sheets above creates a complex yet essential framework for understanding the dynamics of glacier and the broader climate system. Exploring these hidden mountain ranges has demanded a fusion of human curiosity, advanced technology, and persistence. For decades, these landscapes were concealed, invisible to traditional mapping and inaccessible to direct observation. However, with the advent of ice-penetrating radar and sophisticated remote sensing techniques, humanity has pierced through the opaque ice layers to reveal a rugged terrain of unbelievable scale and significance. This discovery has essentially rewritten geological maps and forced scientists to re-evaluate models of ice sheet behavior and global climate feedbacks. The physical characteristics of these mountains, ranging from soaring peaks to deep basins, serve as both barriers and conduits, influencing glacier flow patterns. For example, towering ridges can anchor ice sheets in place, slowing their glide towards the sea, while deep troughs may channel meltwater beneath the glacier, accelerating ice motion through lubrication. This dynamic interface directly impacts the rate at which ice is lost from the Arctic to the oceans, contributing to sea level rise worldwide. Understanding these mechanisms is critical for making accurate predictions about the future state of the planet's ice masses. These mountain ranges are not merely geological structures, they are time capsules preserving detailed records of Earth's climate history. Embedded within bedrock and sediment are traces of warmer eras of ecosystems that flourished long before the establishment of permanent ice covers. Fossil evidence and mineral deposits point to a once much greener Arctic, where rivers carved fertile valleys and supported a diverse array of life forms. Sedimentary layers reveal patterns of glaciation and retreat, offering insight into the natural variability and responses of Earth's climate system over millions of years. One of the most intriguing aspects of these subglacial landscapes lies in their relationship with hidden water bodies. Beneath the ice, networks of liquid water lakes and rivers persist, prevented from freezing solid by pressure and geothermal heat. These subglacial waters play a crucial role in the basal lubrication of glacier, affecting heat transfer and sediment transport and ultimately altering ice dynamics and stability. Changes in the volume and flow of this water can hasten ice sheet disintegration or, in some cases, provide temporary stabilization. Tracking these subglacial hydrological networks is therefore vital for comprehensive climate modeling. The discovery of life thriving in these hidden watery bastions challenges traditional concepts of habitability. Microbial communities living in total darkness, under extreme pressure and cold, survive through chemosynthesis powered by chemical reactions rather than sunlight. Their existence not only broadens our understanding of life's limits on Earth but also serves as an analogue for extraterrestrial environments, where life may exist beneath icy shells of moons or planets. Research into these extremophiles is opening new doors in astrobiology and expanding the search for life beyond Earth. While the potential for discovery beneath the ice is immense, it is accompanied by formidable ethical and logistical challenges. The Arctic's pristine environments must be preserved, demanding strict protocols to prevent contamination both biological and chemical during exploration and sampling. Careful planning governs drilling operations into subglacial lakes, with international regulations ensuring that these fragile ecosystems remain undisturbed as much as possible. Technological advancements aim to reduce human impact, utilizing autonomous vehicles, sterile sampling methods, and remote analyses. The integration of indigenous knowledge into polar research enriches this scientific endeavor. Indigenous peoples in Arctic regions hold deep, nuanced understanding of ice behavior, weather patterns, and ecological interactions, derived from centuries of close observation and adaptation. Collaborations between indigenous communities and scientists foster holistic approaches that respect traditional wisdom and enhance scientific outcomes, supporting the sustainability of research efforts and the well-being of local populations. As Arctic ice continues to melt at unprecedented rates, the unveiling of subglacial mountain ranges compels us to consider global implications. Melting ice contributes to rising sea levels, which threaten coastal cities and island nations around the world. The interactions between bedrock topography and ice flow influence how quickly Greenland's glacier and the Arctic ice sheet lose mass. Accurate data from radar mapping and in situ observations improve climate models, guiding international policy and adaptation strategies critical to humanity's future resilience. Beyond climatic and geological significance, these subglacial mountains embody the spirit of exploration and discovery that defines our species. They invite us to ponder the mysteries hidden beneath the Earth's surface and to appreciate the intricate connections between geology, biology, and climate. Each investigation peels back layers of ignorance, revealing a planet in constant flux, alive, evolving, and responding to both natural and human-induced forces. The study of these mountains also reminds us that knowledge is boundless and that Earth still holds secrets waiting to be unveiled. The challenges of accessing and studying these regions inspire continual technological innovation. Ice-penetrating radar systems grow more sensitive and precise, autonomous underwater drones venture further beneath ice shelves, satellite networks monitor changes with increasing frequency. Together, these tools broaden our vision, allowing continuous surveillance and rapid response to environmental shifts. Ethical stewardship accompanies this scientific progress. Researchers and policymakers recognize the need to protect vulnerable Arctic ecosystems and respect the rights and livelihoods of indigenous communities. International frameworks, treaties, and collaborative initiatives lay the foundation for responsible exploration and sustainable resource management. This multidisciplinary and multinational cooperation is essential to balance curiosity, knowledge acquisition, and conservation. The subglacial mountains beneath the Arctic ice symbolize the profound depths of the unknown left on our own planet in an age dominated by technology and knowledge. Their slow unveiling is a reminder that Earth remains a complex planet filled with hidden worlds that challenge our understanding and fuel our imagination. They stand as majestic monuments to natural history, inviting us to honor Earth's heritage while preparing for an uncertain future. As glacier retreat and new landscapes emerge, these substrates of rock will witness transformations that will redefine the Arctic. Their newly exposed faces will offer direct access to studying tectonic history, climate evolution, and perhaps even ancient biological records frozen within stone and sediment. This opportunity to connect past and future is invaluable, providing a tangible sense of continuity amidst global change. The enduring presence of these mountain ranges beneath the ice also emphasizes the interconnectedness of Earth's systems. Their impact reaches from the microscopic communities in subglacial waters to the weather patterns circling the globe. Understanding the Arctic subglacial mountains, therefore, is not simply an academic pursuit but one with profound ecological, societal, and existential implications. In contemplating these hidden giants, we are called to reflect on our relationship with the environment, a relationship that requires respect, humility, and responsibility. The mountains challenge us to recognize the fragility and resilience of Earth's systems and to act with foresight and care. They remind us that our planet's most remote and secret places are integral to the health of the whole. Looking forward, the continued scrutiny of these subglacial landscapes demands sustained investment in scientific research and education. It urges cross-disciplinary collaborations that link geology, climatology, biology, technology, and indigenous knowledge systems. Such integrated approaches will deepen our understanding and enhance our ability to respond effectively to global environmental challenges. This comprehensive exploration reveals a world beneath the ice that is vibrant, active, and deeply intertwined with global processes. The Arctic's subglacial mountains are not mere relics of the past but living components of Earth's climate machinery. They influence ice sheet stability, glacial melting rates, and consequently, the future of coastal populations everywhere. Thus, journeying beneath the Arctic ice is more than a physical voyage, it is a journey of insight into the forces that shape our world. It is an invitation to witness the complexity and beauty hidden in cold darkness, illuminating the pathways through which Earth's systems operate. As we continue this journey, each new discovery carries the promise of understanding that can guide humanity toward a more informed, compassionate, and sustainable future. In the silent icebound depths, these mountains stand as timeless guardians of Earth's history and future, beckoning all who listen to join in the ongoing quest to explore, discover, and protect the fragile planet we call home. Through this unfolding story, we reconnect with the wild essence of our world and renew our commitment to stewarding its wonders for generations yet to come. The Arctic subglacial mountain ranges serve as profound reminders of the Earth's complexity and vitality, bridging the ancient with the modern and the known with the mysterious. These frozen giants, hidden beneath kilometers of ice, have long been silent players in the planet's story, influencing ice dynamics and climate patterns in ways only recently understood. Their importance transcends their geographic isolation, as they play integral roles in the functioning of the global environment, affecting sea levels, ocean currents, and atmospheric systems across the Earth. As we delve deeper into the study of these hidden mountains, we uncover layers of interconnected systems that exemplify how Earth's processes are multifaceted and interdependent. The subglacial mountain topography shapes how glaciers move, either retarding their flow by providing resistance or enabling faster motion when intersected by deep valleys and water pathways. This nuanced interaction determines how much ice is lost to the oceans and how quickly such changes occur, factors critical for accurately predicting sea level rise and global climate trajectories. The discovery and mapping of these mountains have revolutionized our understanding of polar geology and its influence on Earth's climate system. Previously underestimated and largely invisible, these ranges have revealed a rugged landscape, punctuated by peaks and valleys with the power to direct the fate of massive ice sheets. This revelation demands that scientists integrate detailed topographical data into climate and ice flow models, enhancing their precision and relevance for forecasting future changes. From a geological standpoint, these mountains reveal a dynamic history marked by tectonic collisions, volcanic activity, and episodes of uplift and erosion that shaped the northern continents. This geological narrative stretches across hundreds of millions of years, with the features now concealed beneath ice offering insights into past supercontinents and ancient climatic conditions. Such understanding not only enriches Earth sciences but also provides clues about the processes shaping other planetary bodies. Among the most fascinating features accompanying these mountains are the ancient valleys carved by rivers existing before the ice advanced. These valleys harbor records of a time when the Arctic was temperate, supporting diverse ecosystems and flowing rivers. Their preservation beneath ice allows reconstruction of past environmental conditions, shedding light on historical climate fluctuations and informing predictions about how the Arctic landscape may evolve under anthropogenic warming. The subglacial hydrological networks built around these mountains significantly influence glacier dynamics and ice sheet stability. Lakes, rivers, and channels of liquid water exist beneath the ice, sustained by intense pressure and geothermal heating. These water bodies form lubricants at the interface between ice and bedrock, affecting glacier velocity and contributing to ice sheet mass balance changes. The distribution and behavior of subglacial water are complex and highly variable, underscoring the need for ongoing radar surveys and modeling efforts. Explorations into these icy depths have revealed microbial life thriving in isolated, extreme conditions, pushing the boundaries of biology and expanding ideas about where life can persist. These extremophiles harness chemical energy sources independent of sunlight, an adaptation that intrigues astrobiologists seeking analogues for extraterrestrial life forms. Studying such unique ecosystems informs not only terrestrial biology but also the search for life on icy worlds elsewhere in the solar system. While the scientific promise is vast, research in the Arctic is tempered by ethical considerations and logistical constraints. The need to protect fragile, previously undisturbed subglacial environments guides stringent protocols for sampling and exploration to prevent contamination. Advances in drilling technology and robotic submersibles help minimize human impact while maximizing scientific discovery, balancing curiosity with responsibility. Integration of indigenous knowledge enriches scientific understanding and promotes respectful, culturally sensitive research. Indigenous peoples' extensive experience with Arctic landscapes and climates contributes invaluable perspectives, fostering collaborative approaches that honor traditions and boost the relevance and acceptance of scientific findings within local communities. The consequences of ongoing Arctic ice melt reverberate worldwide. Rising seas threaten billions, altering coastlines, economies, and ways of life. The fate of glacier and ice sheets intertwined with the hidden mountains beneath the ice has thus become a matter of global significance. Accurate prediction of contributions to sea level rise depends heavily on detailed topographic and hydrological understanding, making research in this field critical for adaptation and mitigation strategies. These concealed mountain ranges remind us that Earth remains a planet of vast mysteries and continuous discovery, encouraging humility in the face of natural complexity. They urge us to increase investment in scientific research, foster international cooperation, and develop the technologies needed to explore and protect our most remote environments. Their emergence from beneath the ice symbolizes a larger narrative of revelation and transformation both for nature and for our relationship with it. Studying these ancient peaks reinforces how interwoven the Earth's systems are and how changes in one part can have widespread effects. Understanding and stewardship of these systems are vital as humanity confronts the challenges of climate change. The Arctic subglacial mountains compel us to consider our role as guardians of the planet. They invite us to think deeply about sustainability, resilience, and the responsibilities entailed in unfolding Earth's secrets. Their stories, enshrined in stone and ice, connect past, present, and future, emphasizing the importance of knowledge, respect, and care in our interactions with the Earth. With each technological advancement, with each expedition beneath the ice, we reveal facets of a world that has long remained hidden. This journey is far from over. The mountains beneath the Arctic ice call us forward to explore, to learn, and to act, all in the name of preserving the delicate balance of our global home. Their silent grandeur underlines the awe-inspiring power and mystery of the natural world, a testament to the endless frontiers that still await humanity's discovery. In this unfolding chapter of exploration, we find hope, inspiration, and a renewed commitment to understanding our planet intimately and responsibly. Ultimately, the Arctic's buried mountain ranges serve as eternal witnesses to Earth's enduring spirit, a spirit of change, resilience, and infinite marvel. They beckon us to listen, to observe, and to protect. They remind us that beneath the silent ice, life pulses, history endures, and the future waits quietly for those willing to uncover it with care and wisdom. The Arctic's subglacial mountains stand as monumental testaments to the dynamic processes that have shaped our planet's surface and continue to influence its future. Beneath the thick ice sheets that blanket the polar region lies a landscape once hidden in mystery, now gradually illuminated by advanced technologies and tireless scientific inquiry. These hidden giants offer a window into Earth's geological and climatological past, presenting clues that help scientists unravel the complex interplay between tectonic activity, glaciation, and environmental change. The discovery and ongoing exploration of these subglacial mountain ranges challenge early assumptions that the Arctic Ocean floor was a relatively featureless basin. Instead, we now recognize it as a terrain of immense relief, characterized by steep ridges, deep valleys, and intricate patterns carved by ancient geologic forces. This topographic complexity has profound implications for the behavior of overlying ice sheets. It influences ice flow mechanics, meltwater drainage, and ultimately the stability of Arctic glacier in a warming world. Ice-penetrating radar technology has permitted unprecedented views beneath the ice, transforming these once inaccessible landscapes into detailed maps of the hidden terrain. Radio waves emitted by radar systems penetrate the ice, reflecting off rock surfaces and other interfaces below, enabling scientists to reconstruct three-dimensional models of the sub-ice topography. These models reveal vast mountainous regions that rival or exceed surface mountain ranges in height and extent, reshaping our understanding of Arctic geology. Tectonic processes responsible for the formation of these mountains are ancient, stretching back hundreds of millions of years to periods when continents collided, rifted apart, or were shaped by volcanic activity. The remnants of these forces persist beneath the ice, their forms preserved despite the covering glacial masses. Understanding the formation and evolution of these subglacial mountains provides valuable insight into Earth's lithospheric dynamics and the assembly of northern continents. Beyond the structural geology, these mountains have preserved sedimentary deposits and fossils that reveal snapshots of past climates and ecosystems. Before ice sheets engulfed the region, the Arctic supported diverse habitats with flowing rivers, forests, and abundant life. Embedded sediments and organic matter captured in these hidden valleys now offer clues about polar conditions during greenhouse periods when the Earth was significantly warmer. Studying these ancient environments aids scientists in understanding Earth's climate variability and the mechanisms driving it. The intricate web of subglacial hydrology interwoven with these mountains exerts tremendous influence over glacier dynamics. Subglacial lakes, rivers, and water channels lubricate the base of the ice sheet, modulating its motion and longevity. As temperatures rise and the Arctic warms, the volume of subglacial meltwater fluctuates, with complex effects on ice flow speed and stability. These hydrological features also participate in sediment transport and nutrient cycling beneath the ice, with broader ecological ramifications. Life itself persists in these hidden aquatic niches. Microbial communities thriving in subglacial lakes challenge traditional definitions of habitable conditions and demonstrate life's extraordinary resilience. These organisms, reliant on chemical rather than solar energy, are models for understanding potential extraterrestrial life forms on icy moons like Europa and Enceladus. They highlight the Arctic subglacial environment as a critical natural laboratory for astrobiology and extremophile biology. Scientific expeditions to sample these hidden ecosystems must navigate formidable challenges. Extreme cold, ice thickness, and the need to prevent contamination necessitate careful planning and use of advanced, minimally invasive technologies. International cooperation and robust ethical frameworks underscore the importance of balancing exploration with conservation. Indigenous Arctic populations provide invaluable insights into the environment through generations of traditional knowledge. Their understanding of ice behavior, seasonal cycles, and ecological shifts complements scientific research, enriching interpretation and fostering collaborative stewardship. Respecting indigenous rights and integrating local knowledge have become central principles in Arctic research initiatives. Melting Arctic ice and retreating glacier underscore the urgency of understanding the subglacial mountain system's role in global climate. Changes triggered in these mountains influence glacier response and contribute to sea level rise, affecting millions worldwide. High-resolution data on Arctic bedrock topography and subglacial hydrology improve projections and inform climate adaptation strategies essential for vulnerable communities. These mountain ranges symbolize the boundless opportunities and responsibilities inherent in Earth exploration. While technology has unlocked deeply concealed realms, the complexity unveiled continues to prompt questions about Earth's past and future. Human curiosity drives continued study, yet it is moderated by an awareness of the ecological fragility of these remote regions. Technological advances continue to expand data acquisition capabilities, including enhanced radar imaging, autonomous exploration vehicles, and satellite missions providing continuous monitoring. Integration of these tools with computational modeling enables comprehensive analyses linking local subglacial features with global environmental trends. As the Arctic environment evolves rapidly, the knowledge gained about these mountains informs not only scientific inquiry but also policy and governance. Coordinated global efforts ensure that exploration proceeds with environmental sensitivity and social responsibility. Effective management and protection of polar regions require the synthesis of scientific data, indigenous perspectives, and international agreements. The subglacial mountains stand as solemn reminders of Earth's hidden grandeur and the ongoing narrative of planetary change. Each newly discovered ridge or valley reveals layers of geological history and climatic information that enrich our understanding of Earth's systems. They exemplify the interplay between the solid Earth and dynamic ice, bridging epochs and illuminating extreme environments. Reflecting on these mountains invites a broader contemplation of humanity's role within the natural world. They urge respect for the complexity and vulnerability of Earth's ecosystems and highlight the importance of learning from nature's long-term cycles. This understanding fosters a deepened commitment to sustainability and environmental guardianship. The gradual emergence of these mountain systems from beneath melting ice represents not only a physical transformation but also an invitation to broaden perspectives on planetary stewardship. As nations and scientists explore these hidden worlds, the imperative to preserve Arctic integrity intensifies amid global climate uncertainties. Continued exploration promises to uncover further secrets locked beneath the ice signatures of ancient civilizations shaped by natural forces, hidden biological reservoirs, or new geological phenomena yet to be imagined. The mystery of these subglacial mountains fuels the human spirit of discovery and the quest for knowledge. Embedded within these mountains is a story of resilience of Earth enduring through shifting climates, tectonic upheavals, and cycles of ice and warmth. Their silent presence beneath the Arctic ice connects us to deep time and to the forces shaping the planet's future. Understanding the myriad roles these mountains play, from influencing glacial motion and climate feedbacks to harboring life in extreme isolation, is vital for developing holistic frameworks to address climate change. Without grasping these complexities, predictions remain incomplete, risking inadequate responses to accelerating environmental threats. These peaks and valleys beneath the ice illustrate how seemingly distant systems are deeply entwined, urging a systems thinking approach that encompasses geology, biology, meteorology, and human dimensions. Recognizing these connections enhances global cooperation and informed decision-making. The Arctic's subglacial mountains thus serve both as a scientific frontier and a call to action. They beckon global communities to invest in research, technology, and conservation efforts that honor the planet's integrity. Their study enriches humanity's collective understanding and inspires reverence for Earth's hidden wonders. In the quiet darkness beneath the ice, these mountains hold mysteries awaiting revelation, a testament to Earth's enduring vitality and the power of human curiosity. They remind us that discovery is a continual journey, a tapestry woven across time, inviting us to explore, protect, and cherish the world beneath our feet and beneath the ice. Through these endeavors, humanity can forge a future where knowledge guides stewardship, where understanding fosters sustainability, and where the Arctic's hidden mountains stand not only as relics of the past but as pillars supporting the Earth's resilient future. Their narrative weaves scientific insight with human passion, charting a path forward amid the vast, changing tapestry of our planet. The Arctic subglacial mountains are among Earth's most profound enigmas, veiled in ice yet illuminated through the persistent efforts of scientific exploration and technological advancement. These majestic ranges, buried beneath kilometers of frozen crust, hold stories that span geological epochs, climate revolutions, and the subtle interplay between ice, rock, and life. Their discovery and analysis not only transform our understanding of the Arctic landscape but challenge humanity to consider the broader implications of hidden natural worlds on the planet's health and our collective future. One of the most striking revelations from studying these mountains is how fundamentally intertwined their existence is with the stability and dynamics of the Arctic ice sheets. These mountains serve as the bedrock skeleton, shaping the flow and behavior of glacier that ultimately determine the fate of vast volumes of ice poised on the edge of melting. Variations in elevation and morphology create a complex system of barriers and channels that dictate how ice moves, where it accumulates, and how it discharges into the surrounding oceans. This dynamic decisively affects the contribution of Arctic ice melt to global sea level rise, which threatens coastal ecosystems and human settlements worldwide. The precision to peer through thick ice sheets comes primarily from advances in ice-penetrating radar, a technology that revolutionizes polar research by allowing detailed mapping of the subglacial topography. Radar pulses sent through ice layers bounce back from interfaces beneath, returning signals that can be reconstructed into detailed images of mountains, valleys, and even subglacial water bodies. These comprehensive maps provide scientists with critical data to understand the spatial variability of ice flow, detect regions prone to rapid change, and identify areas where subglacial lakes may concentrate microbial life. Geologically, these mountain ranges are vestiges of ancient, active tectonic processes that shape the northernmost continents of the Earth. They were formed through continental collisions that pushed up rock formations, volcanic activity that reshaped landscapes, and millions of years of erosion that carved valleys and peaks. Despite their burial beneath glacier, their composition and structure remain remarkably well preserved. Investigating these formations helped scientists reconstruct Earth's tectonic evolution, shedding light on processes that also occur on other planetary bodies. Sediments and fossils embedded within subglacial valleys offer a compelling narrative of a bygone era when the Arctic was a vastly different place. Long before polar ice caps took root, the region experienced warmer climates that supported rich ecosystems fed by rivers and lakes. The well-preserved subglacial valleys enable researchers to study sedimentary records revealing cycles of warming and cooling, biological diversity, and environmental transformations. These insights not only reconstruct Earth's past environments but inform predictions about future climate trends under anthropogenic influence. Interlaced with these mountains is an extensive network of subglacial water systems consisting of lakes, streams, and rivers maintained in liquid form beneath immense pressure and geothermal heat. These subglacial hydrological features are critical agents controlling ice sheet behavior. Water at the ice-rock interface acts as a lubricant, allowing glacier to slide more swiftly toward the ocean. The volume and distribution of subglacial water vary seasonally and with changing climate conditions, heavily influencing glacier velocity and stability. Mapping these features with radar technology and integrating hydrological models are key to understanding and projecting ice dynamics. The biological dimension of these environments is as remarkable as it is mysterious. Discovery of microbial life thriving in subglacial lakes challenges preconceived limits of life's adaptability. These microorganisms subsist in complete darkness and in conditions of extreme cold, pressure, and chemical isolation, deriving energy from geochemical processes rather than sunlight. The study of these unique life forms provides invaluable clues about the resilience of life on Earth and informs the search for life on icy worlds beyond our planet, such as Europa and Enceladus in our solar system. Careful stewardship is vital for scientific exploration to protect these pristine subglacial habitats. International agreements and protocols guide researchers to minimize contamination during sampling and drilling operations. Innovative technology, including sterile drilling rigs and robotic exploration vehicles, enhances the ability to study these environments while preserving their ecological integrity. Ethical considerations underscore the responsibility to explore without harming the very systems we seek to understand. The voices and knowledge of indigenous Arctic peoples enrich this scientific endeavor. Indigenous communities, through generations of close interaction with their environment, hold profound observational knowledge about ice behavior, climate fluctuations, and ecosystem dynamics. Collaborative research efforts that respect and integrate this traditional knowledge foster more comprehensive and sustainable approaches to Arctic study and environmental management. The rapid changes unfolding in the Arctic due to global warming heighten the urgency of understanding the subglacial mountain systems and their role in ice sheet dynamics. Polar ice losses currently contribute significantly to global sea level rise, influencing global climate systems and human societies. Detailed and accurate data about the bedrock topography and subglacial hydrology are essential for improving climate models and developing effective adaptation strategies to mitigate adverse impacts. These mountains symbolize the endless quest for knowledge and the limitless marvels our planet holds. Each breakthrough in mapping and exploration reveals further mysteries, underscoring the importance of persistent scientific inquiry, interdisciplinary collaboration, and sustained technology development. The complex interplay of geology, hydrology, biology, and climate beneath the Arctic ice demands integrative and holistic research methodologies. Technological innovation continues to drive this frontier of discovery, with advances in remote sensing, autonomous exploration, and big data analytics enhancing the capacity to monitor and understand subglacial environments. Satellites equipped with synthetic aperture radar, airborne ice-penetrating radar surveys, and robotic submersibles represent the cutting edge of this endeavor. These tools provide near-continuous data streams and unprecedented detail, enabling real-time monitoring of ice sheet responses to environmental changes. The research findings extend well beyond the realm of pure science, informing policy and fostering global cooperation. Protecting Arctic environments, preparing for rising seas, and addressing the intertwined challenges of climate change rely on accurate scientific knowledge combined with effective governance. International cooperation, sustainable resource management, and respect for indigenous rights are foundational to managing and preserving these fragile polar regions. The Arctic's subglacial mountain ranges embody the grandeur and complexity of Earth's natural systems. Through their discovery and study, we deepen our understanding of planetary processes, empower societies to face environmental challenges, and enrich our appreciation for the natural world. These mountains provide critical perspectives about stability and change, resilience and vulnerability, concepts that reflect humanity's own journey within the vast ecosystem of Earth. Embracing the knowledge these mountains reveal invites a broader cultural and philosophical reflection. They challenge us to expand our perception of time, space, and life, reminding us that beneath surface appearances lies a world dynamic, interconnected, and alive. This understanding encourages humility and responsibility, inspiring efforts to preserve the Earth as a home for all its inhabitants. The gradual exposure of these ranges as Arctic ice retreats also symbolizes hope and opportunity. Opportunities for scientific breakthroughs, for enhancing climate resilience, for fostering international collaboration, and for integrating diverse knowledge systems toward common goals. The journey into the Arctic's icy depths is emblematic of human perseverance and our collective desire to explore the unknown. These mountains, silent in their frozen repose, connect us across generations, linking past climates and ecosystems with present-day challenges and future possibilities. They stand as magnificent monuments to Earth's enduring dynamism, inviting continued exploration, discovery, and protection. In the midst of rapid global change, the Arctic's hidden ranges remind us to cherish and respect the planet's intricate complexity. They are symbols of the hidden knowledge still to be uncovered and the intertwined fate of humans and nature. Our continued commitment to uncovering their stories reflects an enduring belief in the power of science and human curiosity to illuminate the mysteries of the natural world, chart a sustainable course for the future, and celebrate the beautiful, boundless intricacies of planet Earth. The Arctic's subglacial mountain ranges embody one of the most profound natural enigmas on Earth, lying cloaked beneath kilometers of eternal ice, silent yet far from inert. The more we uncover about these hidden giants, the more intricate the web connecting geology, glaciology, biology, and climate becomes. They are living proof of Earth's persistent transformation, a gateway into understanding interactions that shape not only the Arctic but global environmental stability. These mountains, which we once believed concealed beneath a featureless ice sheet, have gradually revealed their vast grandeur through ice-penetrating radar and satellite imaging. Each scan unfolds a new chapter, a three-dimensional narrative carved in ancient rock and sculpted by epochs of tectonic upheaval, weathering, and glacial shaping. Their peaks serve as anchors, influencing ice sheet dynamics and turnover, determining where the frozen mantle holds firm and where it yields to pressures that send glacier cascading to the sea. The mechanics of this dynamic relationship underpin our ability to forecast climate change impacts. Peaks and ridges resist ice flow, slowing glacial retreat, while subglacial lakes and channels of liquid water lubricate the ice bed, hastening glacier movement. These nuanced geological features are vital modulators of melting rates, ice velocity, and calving events that contribute to rising sea levels worldwide. Pinpointing how each element interacts requires high-resolution mapping and sophisticated modeling that integrate radar data with glaciological and hydrological insights. Geologists delve into these buried ranges to uncover Earth's long history. The mountains are remnants of immense continental collisions, volcanic activity, and plate tectonics that shaped the planet's surface over hundreds of millions of years. Fossils embedded within rocks and sediments narrate stories of warmer, verdant epochs when the Arctic was alive with thriving ecosystems and flowing rivers, times when polar ice was absent and life flourished against a different climate backdrop. This geological biography helps scientists reconstruct the planet's climatic past, providing vital context for understanding the present shifts we observe. The preserved sediment layers act as natural archives, capturing dust, pollen, and organic matter, revealing ancient environments and cyclical glaciations. This knowledge sheds light on Earth's natural variability and the mechanisms that trigger transitions between ice ages and warmer interglacials. Subglacial hydrology emerges as a key player in this story, with interconnected lakes, rivers, and channels lying beneath the ice. These hidden waterways, sustained by immense pressure and geothermal heat, lubricate basal ice, influencing flow rates and stability of glacier. Changes in subglacial water volume can significantly alter ice sheet dynamics, hastening glacier acceleration or providing temporary stability, revealing a delicate balance affected by global temperature changes. Astrobiologists and microbiologists find extraordinary interest in these subglacial habitats. Microbial ecosystems thrive in complete darkness, under crushing pressure and freezing temperatures, obtaining energy through chemical processing rather than photosynthesis. These extremophiles redefine life's boundaries on Earth and provide analogues to potential life in extraterrestrial icy environments, such as the subsurface oceans of moons like Enceladus or Europa, expanding our cosmic perspective. Scientific efforts to access and study these inaccessible worlds impose stringent ethical practices. Protocols enforce minimal disturbance and contamination prevention in these pristine environments. Specialized sterile drilling methods and robotic explorers ensure scientific integrity. These precautions respect the sanctity of these ecosystems and safeguard scientific validity, reaffirming humanity's commitment to responsible exploration. The role of indigenous peoples in Arctic research has proven invaluable. Their long-standing experimental knowledge of environmental patterns, ice behavior, and ecosystem dynamics complements scientific data, enriching understanding and supporting culturally sensitive research. Collaborations foster respect and shared goals, ensuring research benefits local communities while preserving traditional practices and rights. Melting Arctic ice due to climate change accelerates the exposure of these mountains and reshapes the polar environment with rapidity unmatched elsewhere on Earth. The impacts reach far from the Arctic, influencing sea levels, weather systems, and geochemical cycles. Detailed understanding of subglacial topography and hydrology is thus pivotal to improving global climate models and crafting effective environmental policies. Each mountain and valley unveiled enriches science and challenges us to rethink Earth's landscape as dynamic and interconnected rather than static and isolated. The secrets beneath the ice catalyze innovation in technology, from enhanced radar imaging to autonomous underwater vehicles navigating subglacial lakes, continuously expanding our capacity to observe and understand. Global cooperation remains critical in addressing the challenges of polar research, environmental protection, and climate mitigation. International treaties and governance frameworks direct policy, ensuring research is conducted ethically and sustainably. This collective approach balances scientific advancement with environmental stewardship and indigenous sovereignty. The Arctic's hidden mountain ranges represent a nexus of knowledge, where geology, climate, biology, and culture intersect. Their study connects local phenomena with planetary systems, demonstrating the scale and complexity of interrelationships governing Earth's environment. Insights from these ranges thus inform not only academic fields but also practical applications in climate preparedness and ecological conservation. By revealing the Arctic's subterranean landscapes, humanity gains profound insights into Earth's resilience and vulnerability, lessons vital for navigating an uncertain future shaped by human influence. These mountains inspire a renewed sense of wonder and responsibility, urging commitment to preserving the remarkable and fragile polar wilderness. As these ranges emerge from icy shadows, they embody the promise of discovery, a call to scientists, policymakers, and citizens alike to engage with and protect our planet. They challenge us to embrace humility before nature's grandeur and complexity, recognizing that even now, so much remains undiscovered and interconnected. Through continued exploration, technology, and respect for traditional knowledge, the Arctic's subglacial mountains will guide us towards deeper understanding and wiser stewardship. They stand not only as geological formations but as enduring symbols of Earth's dynamic story, a story woven into the fabric of climate, life, and human existence. In their silent majesty beneath the ice, these mountains wait to share remaining secrets that promise to reshape scientific paradigms and deepen our connection to the natural world. Their journey from hidden obscurity to illuminated understanding mirrors humanity's quest for knowledge, a journey marked by curiosity, reverence, and the enduring desire to uncover the mysteries of our blue planet. The Arctic's subglacial mountains are a profound testament to the dynamic and evolving nature of our planet. Buried beneath vast expanses of ice, these ancient ranges have remained hidden for millennia, holding within their rugged contours secrets that cannot be found anywhere else on Earth. As science continues to unveil their mysteries, we are granted an extraordinary vantage point from which to understand Earth's geological history, climate system, and the intricate interplay between ice, rock, and life that sustains the Arctic and influences the global environment. The relationship between the subglacial mountains and the overlying ice sheets is a complex one. These mountains form the foundation upon which glacier and ice flows rest, their heights and shapes controlling the paths and speeds of ice as it journeys toward the ocean. Elevated peaks act as anchors, stabilizing large sectors of the ice sheet, while deep valleys and basins can funnel meltwater, creating lubricated pathways that accelerate ice movement. The nuanced topography beneath the ice sheet thereby plays a pivotal role in the stability and velocity of glacial systems, which directly feed into global sea level projections. Advances in ice-penetrating radar technology have been instrumental in revealing the scale and detail of these hidden features. By sending electromagnetic waves through ice and analyzing the signals reflected back from the bedrock beneath, scientists generate detailed three-dimensional maps of the subglacial landscape. These maps have transformed our understanding of the Arctic from a smooth, featureless ice-covered region to a terrain of towering mountains, deep valleys, and extensive networks of subglacial lakes and rivers. The tectonic history preserved in these mountain ranges dates back hundreds of millions of years. They testify to the forces that shaped the northern continents through continental collisions, rifts, and volcanic activity. These processes sculpted the lithosphere, leaving behind the peaks and troughs that have persisted beneath ice sheets long after their surfaces were obscured. By studying the geological composition and structure of these ranges, scientists reconstruct Earth's ancient environments and tectonic evolution, providing essential context for understanding current geological activity and future trends. Within the valleys and basins of this hidden terrain lie sedimentary layers rich in fossilized materials and organic evidence. These records reveal times when the Arctic was far warmer and capable of supporting diverse ecosystems, with flowing rivers and vegetative landscapes. The preservation of such deposits beneath the ice allows paleoclimatologists to draw refined conclusions about past climate states, transitions, and the natural variability that governs Earth's climatic cycles. The subglacial hydrological systems interleaved within this mountainous terrain are critical drivers of glacier dynamics. Lakes, channels, and rivers of liquid water, sustained by geothermal heat and pressure, infiltrate the ice bedrock interface, lubricating the base of glacier and influencing their rate of movement. This meltwater's behavior depends on seasonal and climatic factors, and its fluctuations can either accelerate or retard ice flow. Mapping these water systems through radar and hydrological modeling is therefore essential for forecasting glacier evolution and sea level contributions. Intriguingly, life has also found a foothold in this extreme environment. Extremophile microbial communities inhabit subglacial lakes and rivers, thriving in complete darkness, extreme cold, and high pressure. These life forms subsist on chemical reactions facilitated by interactions between water and rock, expanding our awareness of the resilience and adaptability of life. Research in this realm not only informs terrestrial biology but also frames our search for possible life on icy extraterrestrial worlds. Studying these fragile environments raises ethical considerations. Rigorous protocols are in place to minimize contamination during drilling and sampling, preserving the ecological integrity and scientific value of these pristine ecosystems. Cutting-edge technology and meticulous mission planning ensure that exploration proceeds responsibly, balancing discovery with conservation. Integrating indigenous knowledge into Arctic research enriches scientific inquiry, offering deep insights garnered over generations of direct observation and interaction with the environment. Collaborative approaches between scientists and indigenous communities facilitate culturally respectful studies that enhance understanding while supporting local stewardship and sovereignty. Climate change has accelerated the melting of Arctic ice, threatening to expose vast areas of these subglacial mountain ranges and reshape the polar environment. This melting has consequences far beyond the Arctic, notably in rising sea levels that affect coastal human populations worldwide. Realistic and refined predictions of ice mass loss rely on precise knowledge of subglacial topography and hydrology. Consequently, continued investment in comprehensive mapping and modeling is imperative for informed global climate policy. The revealing of these mountains aligns with a broader philosophical shift and acknowledgement that Earth's dynamics are far more interconnected and complex than previously understood. It reminds humanity of the delicate balances governing natural systems, inviting humility and a recommitment to scientific rigor and environmental responsibility. Technological advancements have propelled this field forward. Autonomous underwater vehicles, higher-resolution satellite radar, and enhanced data analytics offer unparalleled abilities to observe, analyze, and model the Arctic under the ice. Such tools facilitate near real-time monitoring of ice sheet responses, vital for tracking and understanding rapid environmental changes. International collaboration and treaties protect the Arctic environment, ensuring sustainable development of scientific resources and guarding against overexploitation. These geopolitical frameworks support cooperative scientific efforts that transcend national boundaries, realizing that the Arctic is a shared resource critical for global ecological balance. The discovery of subglacial mountains has deepened our appreciation for the intricate interactions between geological foundations, ice dynamics, and biological systems. These interactions underscore that changes occurring in remote Arctic locales resonate across planetary systems, affecting climates, ecosystems, and human livelihoods globally. These hidden ranges play a dual role: guardians of Earth's deep history and sentinels of contemporary climate transformation. Their slowly emerging landscapes serve as physical and symbolic bridges linking ancient epochs with contemporary environmental realities, urging mankind toward conscious stewardship. Through ongoing exploration and study, the Arctic's subglacial mountains continue to inspire awe and scientific fascination. They challenge established paradigms, broaden the horizons of interdisciplinary science, and emphasize the continuous nature of Earth's evolution. We are reminded that Earth holds many undiscovered realms, each with unique insights into the fabric of life and geology. The mountain's revelation reinforces that exploration, curiosity, and respect are key to unlocking and preserving the planetary legacy. As climate change alters polar ice and exposes ever more of these mountains, we face a crucial moment to integrate knowledge across science, policy, and culture to ensure resilience and sustainability for current and future generations. These landscapes reveal the intertwined destinies of humans and the natural world, urging global cooperation and enlightened action to protect the fragile Arctic environment. The silence beneath the ice is not emptiness but a repository of Earth's secrets, a narrative of endurance and change that we are only beginning to comprehend. In embracing this narrative, we embrace the responsibility to understand and protect our planet holistically, fostering harmony between scientific discovery and environmental integrity. The Arctic's subglacial mountain ranges stand as monumental symbols, a reminder of Earth's layered history, the resilience of life, and the imperative of stewardship in a rapidly changing world. Their continuing story is a testament to human ingenuity, curiosity, and the enduring quest to uncover the Earth's deepest mysteries, inspiring hope for a sustainable future amid challenges to come. The Arctic's subglacial mountains stand as monumental witnesses to Earth's ongoing evolution, long buried beneath vast sheets of ice that have shaped our planet's climate and geological history. As technological innovations and scientific exploration peel back the layers of ice, these hidden peaks and valleys reveal a dynamic landscape of massive proportions and profound significance. Beneath the seemingly unbroken white surface lies a rugged terrain carved by tectonic forces and ancient processes, now trapped in a frozen time capsule. These mountains influence the very behavior of the ice above them. Their towering summits act as natural anchors, slowing the flow of glacier and stabilizing massive sectors of the Arctic ice sheet. By contrast, deep valleys and subglacial water channels facilitate the accelerated movement of ice, allowing meltwaters to lubricate glacier bases and expedite ice discharge into surrounding oceans. This interplay is crucial for understanding the Arctic's role in the global climate system. The way glaciers respond to warming temperatures depends on the underlying topography sculpted by these mountains. Accurate modeling of ice sheet dynamics demands detailed knowledge of their shape and structure, which ice-penetrating radar and other remote sensing methods now provide. These tools allow scientists to create three-dimensional reconstructions of the terrain beneath the ice, achieving resolutions that reveal intricate mountain ridges, valleys, and subglacial lakes. From a geological perspective, these ranges formed over hundreds of millions of years as a result of plate tectonics, continental collisions, volcanic activity, and crustal deformation have left hides of rock that remain hidden beneath kilometers of ice. Studying the composition and structural details of these ridges provides insight into Earth's ancient past, including periods when the Arctic region was home to lush forests, flowing rivers, and thriving ecosystems under much warmer climates. Sedimentary deposits preserved in subglacial basins and valleys contain fossils and organic matter that chronicle environmental changes predating the Ice Age cycles. These data help reconstruct past climate oscillations, including glacial and interglacial periods, giving context to current shifts accelerated by human activity. These records are invaluable for scientists seeking to understand climate mechanisms and predict future transformations. Hydrologically, these mountains play a key role in shaping networks of subglacial lakes and streaming water beneath the ice sheet. These liquid water bodies exist due to immense pressure and geothermal heat, influencing glacier dynamics by lubricating the interface between ice and bedrock. Seasonal and climate-related variations in subglacial water flow dramatically affect glacier velocity and stability, modulating rates of ice loss critical to sea level rise estimations. Discoveries of unique microbial life thriving in subglacial lakes astonishingly show that biology persists in extreme conditions once thought inhospitable to life. These microbes operate without sunlight, relying on chemical energy sources derived from water-rock interactions. Their existence not only expands knowledge of life's resilience on Earth but also informs astrobiological studies on the possibility of life in the subsurface oceans of icy moons elsewhere in the solar system. The endeavor to study these hidden subglacial environments poses significant ethical and logistical challenges. Preventing contamination during sampling is paramount, necessitating stringent international protocols and carefully designed sterile drilling techniques. Advances in robotic exploration and remote sensing technology reduce human impact, allowing more thorough yet responsible scientific investigations. Indigenous knowledge remains a vital complement to the scientific understanding of Arctic environments. Indigenous Arctic communities hold centuries of experimental knowledge related to ice dynamics, weather patterns, and ecosystem changes. Collaboration between indigenous peoples and scientists fosters mutual respect and ensures that research efforts are culturally sensitive and beneficial to all stakeholders. The rapid thawing of Arctic ice intensifies the urgency to understand the underlying subglacial mountains. These melting processes contribute significantly to global sea level rise, threatening millions of people living in coastal regions worldwide. Precise data on mountain topography and subglacial hydrology enhance climate models, enabling accurate projections upon which to base adaptation and mitigation measures essential for sustainability and human safety. These mountain ranges inspire not only scientific curiosity but also philosophical reflection. They remind humanity that beneath apparent stillness lies a world of ongoing transformation, of interconnections between Earth systems that extend from microcosms beneath the ice to global climate phenomena. They urge a renewed appreciation for Earth's complexity and call for responsible stewardship by those who seek to unravel its mysteries. Technological advancements continue to push the boundaries of discovery. Improvements in radar resolution, autonomous gliders, and high-throughput data analysis provide unprecedented access to subglacial terrain and evolving ice dynamics. continuous satellite surveillance complements targeted airborne campaigns, creating comprehensive temporal and spatial datasets crucial for long-term monitoring and research. International cooperation underpins successful Arctic exploration and sustainable management. Treaties and collaborative scientific ventures encompass a shared commitment to protecting fragile polar ecosystems while promoting open scientific inquiry. This cooperative spirit ensures that exploration proceeds ethically, and findings inform global environmental policy. Through their interplay with the Arctic ice sheet, subglacial mountain ranges influence not only local geography but global climate and human well-being. Their discovery has enriched understanding of Earth's interconnected systems and enhanced predictive models critical to future planning. These ranges stand as ancient sentinels beneath the ice, their silent majesty beckoning us toward deeper exploration. They connect Earth's geological past with current environmental issues and future possibilities, urging humanity to embrace a holistic approach to planetary science and conservation. The unfolding story of these frozen giants reveals the endless cycles of creation, destruction, and renewal integral to Earth's dynamics. It prompts recognition of our responsibilities as caretakers of a planet whose processes we are only beginning to comprehend fully. The Arctic's subglacial mountains embody the spirit of scientific discovery that defines progress. They challenge us to extend our technological reach, deepen our understanding, and act judiciously in the face of ongoing global change. As the ice above retreats and exposes new facets of this hidden realm, unprecedented opportunities arise for interdisciplinary research, bringing together geology, climatology, biology, and technology. This synergy will illuminate Earth's past and inform adaptive strategies vital to human and ecological futures. Through the silent whispers of these subglacial ranges, Earth tells its ongoing story and narrative of resilience, transformation, and interconnectedness, inviting all who listen to join in a shared quest for knowledge and sustainability. This living legacy beneath the Arctic ice invites profound engagement, inspiring awe and responsibility, reminding us that the most profound discoveries often lie beneath the surface, awaiting patient and respectful exploration. As humanity heeds this call, the hidden mountains beneath the ice will continue to reveal their secrets, enriching understanding and awakening stewardship across generations. The Arctic's subglacial mountain ranges unfold a saga of Earth's persistent transformation beneath an icy veil, revealing landscapes of immense geological history, intricate environmental systems, and surprising biological resilience. These hidden peaks and valleys, once obscured beneath kilometers of ice, are now becoming fundamental to our understanding of the Earth's past, present, and future through innovations in technology and interdisciplinary science. Their intricacies, once unimaginable, weave a complex story that ties the frozen north to planetary processes far beyond. Beneath the seemingly silent ice cap lies a vibrant interplay of geological, climatic, and hydrological phenomena shaped by these mountainous foundations. The subglacial topography determines ice sheet movement, dictates meltwater drainage pathways, and influences the overall stability of the ice. Mountain ridges act as bedrock anchors, resisting and modulating the movement of glacial ice, while deep valleys and basins provide conduits for subglacial waters that lubricate and expedite glacier flow. This complex basal landscape plays an outsized role in how the Arctic ice responds to warming, ultimately affecting global oceans and climate systems. Pioneering ice-penetrating radar technology allows scientists to peer beneath the ice and reveal detailed three-dimensional images of these ranges. The echoes of radar pulses uncover hidden mountain chains, subglacial lakes, and deep basins, providing a vastly improved understanding of icebed interactions. With each dataset, researchers refine models of ice sheet dynamics, enabling more reliable predictions of glacier retreat and informing global forecasts of sea level rise, essential for the billions who depend on coastal stability worldwide. Geologically, the Arctic's subglacial mountains provide records of Earth's tectonic past. Created by ancient continental collisions, rifting, and volcanic processes hundreds of millions of years ago, these ranges anchor the northern continent's lithosphere. Their sediments and rocks preserve records of climatic shifts that have shaped Earth's surface environments through glacial and interglacial cycles. These ancient stories add context not only to geology but also to climate science, offering a window into the mechanisms driving natural climate variability over vast timescales. Subglacial hydrology forms an integral component of the Arctic's hidden mountain systems. Enormous volumes of liquid water exist beneath the ice sheets, maintained by the pressure of overlying ice and geothermal heat. These subglacial lakes, rivers, and channels alter ice dynamics by lubricating glacier beds, influencing the speed and stability of ice flow. Fluctuations in these water bodies in response to seasonal and climate changes further complicate glacier behavior, requiring detailed mapping and modeling to understand their distribution and impact fully. The ability of life to thrive in these seemingly harsh, isolated environments amazes scientists and expands our understanding of biology. Microbial ecosystems adapted to extreme cold, darkness, and pressure thrive in subglacial lakes, sustained via chemical energy sources. Their survival has broad implications for comprehending life's resilience on Earth and its potential existence in the icy oceans thought to lie beneath the surfaces of other celestial bodies like Europa and Enceladus. Exploring these environments necessitates ethical and logistical diligence. Strict global protocols govern sampling and drilling to preserve pristine subglacial ecosystems and ensure scientific integrity. Advances in non-invasive exploration technologies, such as remote robotics and sterile sampling methods, have greatly enhanced researchers' ability to study life and geology deep beneath the ice with minimal ecological impact. Indigenous Arctic communities bring invaluable perspectives, providing centuries of specialized knowledge about the region's environment, weather, and changing ice conditions. Their engagement promotes culturally respectful scientific collaboration, ensuring that research addresses local concerns while benefiting from traditional ecological knowledge. The integration of indigenous wisdom and Western science represents a powerful partnership for Arctic stewardship. The accelerated warming of the Arctic amplifies the importance of understanding these subglacial mountain ranges. Melting ice contributes significantly to sea level rise, threatening millions in coastal regions globally. The detailed topographic and hydrological data gained from studying these ranges feed directly into climate models that inform mitigation and adaptation policies, shaping future strategies to protect vulnerable populations. These mountains also evoke philosophical reflections on human interaction with nature. They remind us of Earth's enduring power and complexity, inviting humility and wonder. They encourage humanity to embrace a systems approach that considers the interconnectedness of geology, climate, hydrology, and biology when confronting environmental challenges. Technological innovations continue to revolutionize Arctic exploration, enhancing data resolution and coverage. Autonomous underwater vehicles navigate beneath the ice to collect critical measurements, while satellite missions provide continuous surveillance. Combined with computational advances in data processing and modeling, these technologies offer profound insights into rapidly evolving cryospheric conditions. Effective international cooperation underpins efforts to study and protect the Arctic. Shared treaties and scientific collaborations foster ethical research, environmental preservation, and sustainable resource management. These partnerships ensure that Arctic exploration serves global interests while respecting local cultures and preserving fragile ecosystems. By studying these mountains, scientists appreciate the scale and complexity of Earth's environmental systems. Their influence extends from microscopic microbial communities in subglacial lakes to global climate cycles and sea level dynamics, underscoring the urgent need for integrated knowledge and coordinated responses to environmental crises. The subglacial mountains symbolize resilience and transformation. Their enduring presence beneath shifting ice and changing climate speaks to the natural cycles of renewal and adaptation. They invite us to see beyond immediate challenges, to seek long-term solutions grounded in science, respect, and cooperation. These landscapes embody humanity's profound quest for knowledge, a journey marked by innovation, perseverance, and ethical responsibility. Our endeavor to understand and protect these regions is a testament to the human spirit and its capacity for stewardship. As the Arctic ice retreats, exposing new facets of these hidden ranges, profound opportunities emerge for discovery and comprehension. We stand at the cusp of new scientific eras, enriched by interdisciplinary insights that will drive global efforts to address climate change and ecosystem preservation. The mountains beneath the Arctic ice are not merely geological features, they are pivotal anchors in Earth's natural systems, guiding glacier, influencing climates, and nurturing life in extreme environments. They serve as powerful symbols of our planet's interconnectedness and the challenges facing its future. Their slow unveiling reminds us of the vast unknowns that remain on Earth and the enduring importance of curiosity, collaboration, and conservation. As new data flows in and understanding deepens, humanity's path towards sustainable coexistence with the natural world becomes clearer. Through the prism of these icy giants, we glimpse the delicate intricacies and enduring forces that define our planet. They are narratives of power and fragility, history and hope, urging us to act wisely to preserve the Earth's splendor and balance. In this unfolding story, the Arctic's subglacial mountains stand as eternal sentinels, mysteries to be unraveled, treasures to be protected, and guides leading us toward a future defined by knowledge, respect, and harmony with the environment. They beckon us to continue the journey of exploration with reverence and resolve, shaping a legacy of stewardship for generations to come. The Arctic's subglacial mountains stand as the silent, majestic keepers of Earth's hidden history and the guardians of its unfolding future. Buried for millennia beneath an ice cap that we once thought was a simple, inert barrier, these mountain ranges have emerged through the tireless work of scientific discovery as portals to understand the deep connections between geology, climate, hydrology, and life itself. Their revelation is not only a triumph of human curiosity and technological innovation but also a profound invitation to reconsider our place within the natural world. From the colossal tectonic forces that forged their peaks hundreds of millions of years ago, to the delicate microbial ecosystems thriving in subglacial lakes, these mountains offer a panoramic narrative of Earth's resilience and change. They have weathered great climatic upheavals, periods of lush warmth and extensive glaciation, keeping locked within their valleys and ridges a record of transitions that echo through the present and into our future. Through their influence on ice sheet dynamics, they also serve as crucial regulators in the global climate system, determining the pace and scale at which ice is lost to the oceans and seas rise. The technology enabling us to peer beneath kilometers of ice-penetrating radar, autonomous submersibles, infrared and satellite imaging has opened a door once considered impenetrable. With each pulse of radar sent through the Arctic ice, with every remote expedition to subglacial lakes and microbial ecosystems, humanity extends its gaze into one of nature's final frontiers, unpacking layers of mystery and knowledge that enrich our understanding of life, Earth, and even the cosmos. Yet, this newfound knowledge comes with great responsibility. The fragile subglacial environments demand respectful stewardship and sustainable exploration, guided by stringent ethical considerations and international collaboration. Indigenous knowledge, with its deep connection to the Arctic landscape, complements scientific inquiry, reminding us that human interaction with nature is both ancient and evolving, requiring balance and humility. As the Arctic ice continues its rapid transformation, exposing more of these secluded mountain ranges, we stand at a threshold. We face sobering realities of climate change, rising seas, and shifting ecosystems, but we also embrace unparalleled opportunities for discovery and innovation. These mountains offer not just data and scientific insight but a profound lesson: the Earth is a vast, interconnected web of forces and life, each component essential to the other. In concluding this journey, the subglacial mountains remind us of endurance and renewal. They are monuments of natural history, keepers of frozen secrets that tell a story of persistence through time and change. They inspire wonder and responsibility, beckoning us to cherish our planet's wonders and act with wisdom and foresight. The hidden peaks beneath the Arctic ice are more than mere geological formations. They are symbols of Earth's enduring vitality and humanity's quest for knowledge. They challenge us to be better custodians of the planet and invite us to explore with reverence the mysteries still concealed beneath the surface. As the final ice melts, revealing the ruggedness once thought lost to time, these mountains will stand as eternal witnesses to Earth's story and humanity's journey. They beckon future generations to continue exploring, learning, and protecting the delicate balance of life and nature. In their silent, steadfast presence, the Arctic's subglacial mountains offer a timeless message: the Earth, in all its complexity and grandeur, is a treasure to be understood deeply and cared for profoundly. Through knowledge, respect, and collective action, we can ensure that this magnificent legacy endures, an enduring testament to our planet's past triumphs and a beacon guiding us into a sustainable future. This is the story of the Arctic's hidden mountains, ancient, mysterious, and alive beneath the ice, a story that continues with every discovery, every question, and every act of stewardship, inviting all of us to be part of the ongoing journey in harmony with the natural world.